So whatever the values are given, you have to write the rankings of these values. What is the formula for rank correlation? It is 1 minus 6 sigma d square divided by n cube minus n. So if a rank is repeating 3 times, then m equals 3. If the rank is repeating 2 times, then m equals 2. Hello everyone, I am Purnima, faculty in the Department of Commerce and Management, Vidyashram First Grade College, Temple of Excellence, Mysuru. I welcome you all to this session. In this session 4 of Unit 3, we will be having a discussion on Spearman's coefficient of rank correlation. Spearman's rank correlation coefficient. Sometimes we come across ordinal data, that is variables under consideration are not capable of quantitative measurement but can be arranged or ranked in serial order. So, we have those variables where the numbers represent the quality of the variable. So, this is nothing but the qualities are expressed in the form of quantitative data. For example, who is the best singer? Who is the best actor? Who is beautiful? In such situations, Karl Pearson's coefficient of correlation cannot be used. Professor Charles Edward Spearman, a British psychologist, has developed a formula in the year 1904 which gives Spearman's rank correlation coefficient. The formula for rank correlation coefficient is 1 minus 6 sigma d square divided by n into n square minus 1. So, this formula you have to remember in order to calculate the rank correlation, or 1 minus 6 sigma d square divided by n cube minus n. Nothing but n into n square is n cube minus n. So, where rank P, this symbol represents the rank correlation. Then D is the difference of the ranks between the series and N is the number of pairs of the observations. Now, the value of this coefficient also varies between plus 1 and minus 1. When plus 1, there is a complete agreement in the order of the ranks of the two series. Where we get a minus 1, there is a complete disagreement between the ranks of the two series. In the cases there are high or low agreement or disagreement between the two ranks depending on the value and direction of the rank correlation. So, if you get a plus 1, it means that there is a high degree of agreement between the ranks, and if you get a minus 1, then there is a lower degree of agreement between the ranks. Okay. Now we have computation of the rank correlation coefficient. The following is a procedure for computing Spearman's rank coefficient correlation. If the ranks are given, mark the ranks of X as XR1 and the ranks of Y as R2. Now, suppose we are observing the variables. We have a set of variables which is given. So, set 1 and set 2. We have two sets of variables here. Now, for the first set, you can name it as X and the second set, you name it as Y. So, if ranks are given, mark the ranks of X as R1 and the rank of Y as R2. Now, whatever the numbers are given, 10, 15, 25, 8, 9, 30, and again here also will be 12, 14, 18, 2, 4, 9, etc. So, whatever the values are given, you have to write the rankings of these values. So, whatever the values are given, so for the X values it will be R1, for the Y values it will be R2. So, if the ranks are not given, then assign ranks to the data and then mark R1 for X series and R2 for the Y series. Now, how do you assign the ranks? So, you can just choose the lowest number or the highest number for the R1. So, if it is the highest number, then this will be the first rank, then next will be the second rank, then third, fourth, fifth and sixth. So in this way, you can have the ranking in the ascending order of the values or the descending order of the values. Now, the next step is compute the rank differences. That is, you have to have R1 and R2. Here also you have to write the ranks. So this will be the rank 1, rank 2, 3, 4, 5 and 6. Now, the next step will be you have to find the D column. Now, in the D column, we have the difference between R1 and R2. So, the differences between these two ranks, that will be the D column. Then next one is square the rank differences. So whatever the D column you have, you just square the differences, substitute the figures in the formula and obtain the rank correlation coefficient. So once you have the D values, then the next step will be you have to calculate the D square values. Then once you get the D square values, then you have to substitute the values in the formula 1 minus 6 sigma D square divided by n into n square minus 1. So n represents the total number of values which are there in the problem. So what are the number of pairs we have to, for which we have to find out the rank correlation. Now, next we have a problem here. So, two judges have ranked 5 competitors in a beauty contest as shown below. So, this is a problem based on the beauty contest. So, are there 2 judges who have ranked them? So, we have the competitors A, B, C, D and E, and we have judge 1 and judge 2. So, this judge 1 has given a ranking of 2 for competitor A, 5 for B, 1 for C, 3 for D and 4 for E. Now, the judge 2 also, he has given the same ranking for the same competitors. Now, what happens is, the next step is, you have to calculate the D column. So, you will be just subtracting the values here. So, R1 minus R2. R1 minus R2. So, 2 minus 2 is 0. 5 minus 5 is 0. 1 minus 1 is 0. 3 minus 3 is 0. 4 minus 4 is 0. So, you can see here the D column is full of zeros. So, as a result of which the D square also will be full of zeros and sigma D square also is a 0. Now, in the next step, we have 1 minus 6 sigma D square divided by n into n square minus 1. So, this is the formula for rank correlation. So, when I substitute the values here, so here D square represents the 0. If you can see here, sigma D square equals 0. So, that 0 is written here and n represents the number of pairs here. So, they have given us 5 competitors here. So, n equals 5. So, 5 into 5 square minus 1. So, that comes up to 1 minus 0 by 120. So, anything divided by 0 divided by anything is 0. So, we are left with plus 1. Since this rank correlation, so we got the Spearman's rank correlation as plus 1. There is a complete agreement between the 2 judges in assigning ranks to the contestants. So, each of the judges, they have given the same rank to the contestants, as a result of which there is a complete agreement between the 2 judges. Then, the next one is 2 managers are asked to rank a group of employees in order of potential for eventually becoming top managers. The rankings are given below. Compute the coefficient of rank correlation and comment. So, here we have the table here. So, in the table, we have the employees A, B, C, D, E, F, G, H, I, J. So, we have so many employees here and the manager has given the rankings here. So, the manager has given the first rank for C, second rank for B, third rank for E, and the fourth rank for D, fifth rank for G, sixth, seventh, eighth, ninth and 10th. So, the 10 ranks have been given for 10 employees by the manager. Now, for the same employees, the second manager has given his own set of rankings for the employees. So, this will be R1 and this is R2 column. So, this is R1 and this is R2. So, the next column will be R1 minus R2. R1 minus R2 will be 10 minus 9, that is 1. Now 2 minus 4 is minus 2 because this 4 is greater than 2, so we have to carry the negative sign. So 1 minus 2 is minus 1, 4 minus 3 is 1, 3 minus 1 is 2, 6 minus 5, 1, 5 minus 6, minus 1, 8 minus 8, 0, 7 minus 7, 0, 9 minus 10, minus 1. So, in this way, we have to write the D column. So, D is nothing but the difference between R1 and R2. Now, the next step will be squaring the differences. So, 1 into 1, 1 square, 2 into 2, 4, 1 into 1, 1, 1 into 1, 1, 2 into 2, 4, 1 into 1, 1, 1 into 1, 1, 0 into 0 is 0, minus 1 into minus 1 is plus 1. So, when we add all this, we get sigma d square equals 14. So, sigma d square equals 14. I substitute the values. Now, what is the formula for rank correlation? It is 1 minus 6 sigma d square divided by n cube minus n. So, this will be equal to, I know the value of sigma d square. Sigma d square equals 14 and n equals 10 values. So, the 10 values are given here. So, I substitute all the numbers in the formula. 6 into 14 divided by, this is n cube minus n. This will be equal to, when I simplify this, 1000 minus 10. So, 1 minus 84 divided by 990. So, we have a rank correlation of 0.915. Since the rank correlation is 0.915, there is a high degree of positive correlation. It means that there is a close agreement between the managers. So, the managers have agreed. So, almost their assessment is 90% in agreement with each other. So, we can say that there is a close agreement between the managers and then the ranking is reliable. Next, the treatment of tied or equal ranks. The Spearman's formula is based on the assumption that ranks are different. But difficulty may arise in cases where 2 or more ranks are getting equal or common ranks. Now, what is this equal or common ranks? Suppose the ranks are different, then it is fine. But then, suppose it is A, B, C, D and E. And both, suppose C, A and B both get the similar ranks. Then, how do we calculate? What if they are having different ranks, we can easily calculate. But then if there is a tie in the ranks, then how do we calculate the coefficient correlation? Difficulty may arise when 2 or more items are getting equal or common ranks. So this happens while assigning ranks when 2 or more items having the same values or the magnitude. Here you can see both A and B, they are having the same ranking. So what do we do then? Then in such cases, the practice is their rank is put as the average of their ranks. That is, when you are having case where the 2 persons are having the same rank, then we have to take an average of the rank which the items would have got if they would have differed from each other. For example, the 5th, 6th and 7th item value is 30. Suppose there are so many 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So here 5th, 6th and 7th, all of them have got 30. Okay. If for example, the 5th, 6th and 7th item value is 30. If the values are different, say 5th is 30, 6th is 28 and 7th is 25, then the ranks are 5, 6 and 7. But the value is the same, that is 30. So 5, 6 and 7 ranks, we take an average, that is 5 plus 6 plus 7. Now, when all the three are getting the same value, instead of writing 5, 6 and 7, so what do? Is we just add the ranks. 5th, 6th and 7th, they have the same values. Then what we do is 5th, 6th and 7th, the ranks we add and divide it by 3. So we take the average. So the average is 6. Therefore, give 6th rank to the 5th and 6th, 7th items, and for the 8th item, the ranking is 8th as usual. Now, if you have in this data, so if you are having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and if you are having the similar data for 5, 6, 7, then so you are taking an average. So here they have similar ranks for 5, 6 and 7. Then you take an average, you get the average number. So you assign 6 ranks for all the 3. Then for the next one, you take it as usual as the 8th rank. So therefore, give 6th rank to 5th, 6th and 7th items. And for the 8th item, the rank is 8th as usual. Then, if there are common or tied ranks, it is advisable to apply an adjustment or correction factor to the formula. The adjustment is to add 1 by 12. So, when you have the similar ranks, so this, for example, I am just repeating here. So, here there is a tie here between the second and the third rank. So, what do? 2 plus 3 divided by 2. So, this will be 5 divided by 2. So, this will be 2.5 and 2.5. So, this rank is shared between A and B. That is, you take an average of the ranks and then do, and 2.5 and 2.5, and then the next D will get the 4th rank and E will get the 5th rank. So, in this way, we have to do if there is a tie in the ranking. So, if there are common or tied ranks, it is advisable to apply an adjustment or correction factor to the formula. The adjustment is to add 1 by 12. So, we have to add 1 by 12 or m cube minus m or m into m square minus 1 divided by 12 to 6 to sigma d square, where m is the number of times an item or value is repeated. So, in the above example, it is 30 which is repeating 3 times. So, m equals 3. So, if a rank is repeating 3 times, then m equals 3. If the rank is repeating 2 times, then m equals 2. So, this correction factor is to be added for each repeated value in both the series. Suppose in the series 1 and series 2, so we have this repeated ranks here 2, 2, 2, and here also we have some repeated ranks 1, 1, 1. So when you have this again 4, 4, 4, again here 5, 5, 5. So if there are repeated ranks, for each of the repeated ranks, we have to have a correction factor. So this correction factor means you have to write this m cube minus n for every repeated value in the given variable. So in the first instance x, so there are 2 repeated variables. So I have to write this twice. So 1 by 12 into m cube minus m and again 1 by 12 into m cube minus m. Now, in the second one, again I have 2 variables. Then again I have to repeat 1 by 12 into m cube minus m. Again 1 by 12 into m cube minus m. So, depending on the number of values which are repeated in both the series, we have to keep on adding this correction factor. So, this correction factor is to be added for each repeated value in both the series. Therefore, the corrected version of this P formula will be like this. So, this P formula will be 1 minus 6 sigma d square plus 1 by 12 into m cube minus m plus 1 by 12 into m cube minus m plus 1 by 12 into m cube minus m plus 1 by 12 into n cube minus m divided by n cube minus n. So, in this way, if there are 4 values which are repeated, the 4 numbers we have to, 4 correction factors we have to add here. And then, what does this m stand for? The number of times the value is repeated. Suppose the value is repeated only twice, then m equals 12. Then if the value is repeated 3 times, then m equals 3. If the value is repeated 4 times, then m will be equal to 4. So this we have to understand and make the necessary adjustment, and you have to add the correction factors in the formula. So in this way we can compute the Spearman's coefficient of rank correlation with the help of this formula. With this, we come to the end of this session. Hope you have all followed it. Thank you.